Solve the triangle with two sides A equals to 31.1 and B equals to 62.2 and angle A measures 30 degrees. Okay, let us begin. First what we'll do, we're going to construct a triangle ABC. Now for the triangle ABC, the sides opposite to angle A will be denoted by the letter A in lowercase. It has a measure of 31.1 units. The side opposite to angle B, which is AC, will be denoted by the letter B in lowercase, that's 62.2. And then we have the angle measure for A, that is given as 30 degrees. Let's also consider the third side AB. The side opposite to angle C will be denoted by the letter C in lowercase. Our goal will be to solve the triangle, meaning we need to find out the angle measure of B, angle measure of C, as well as the value of the side AB. Now for that, before beginning, what we'll do, we're going to consider the side that is opposite to the given angle. So here in our case we have A. So A here is 31.1. Then we are going to consider the other side being B, and we're going to take its product with sine of the angle that is adjacent to that side B. So here it is 30 degrees, so we'll find out B sine 30 degrees. So B here is 62.2, and we know sine 30 degrees, it has a standard value of 1/2. So this is giving us 31.1. Now clearly we can see here, clearly the measure of side A, that's exactly the same as B times sine of angle A. What does it tell us? Whenever we have this particular criterion, what we get here is a unique solution. So here we have a unique solution. You have a unique solution, and also the given triangle must be a right angle triangle. So let's now check which particular angle of this triangle is right angle. So we're going to use this particular condition. So from the law of sines, we have the ratio A over sine of angle A equals to B over sine of angle B equals to the side C over sine of angle C. That is the law of sine. If we let all of these three ratios equals to some constant lambda, say, then what we can do, in place of A, we can replace it with lambda times sine of angle A. This is going to be equals to B sine A. Now in place of B, we can replace it with lambda times sine of angle B multiplied to sine of angle A. Now immediately we can factor out lambda as well as sine A from both of the two sides, which is going to leave us with 1 equals to sine B. Now 1 equals to sine B, or we can say sine B equals to 1, simply means that angle B measure is going to be 90 degrees. This means that angle B is a right angle. Okay, so we have found out one of the angle. If B is 90 degrees, then we can immediately find out the angle measure for C. So here the angle measure for C, that can be obtained by subtracting from 180 degrees the sum of angle A plus B. So that means C measure comes out to be 60 degrees. So we have successfully obtained the angle measure for C, that is 60 degrees. Now our final task will be to find out the measure of the side C. Now since we have the right angle triangle, so in right angle triangle ABC, which is right angled at B, we can use the Pythagoras theorem to find out the measure of C. So C is going to be the square root of the hypotenuse squared minus the base. The base here is A squared. So we find out the square root of B squared minus A squared. We can substitute B with its corresponding value, 62.2 whole squared, and from it subtract the square of A. So that is 31.1 squared. And this is going to give us 53.866 approximately. So this is going to be the measure of the third side C.